Okay, Brian. Just selfie your face. Where is your laptop or phone? Take your selfie with your laptop or phone. But if you're using your phone, how can you take selfie, right? You have to find someone else to take it for you. Okay, let me check. Alright. Hi, morning. Tak sempat try ataupun tak ada soalan? You can try if you haven't tried until question 47, and we have this Thursday if you want to ask any question, yeah? Okay. We'll continue. We finished basis, okay? The next one is transition matrix. Okay, before that it's coordinate vector and change of basis. Okay, alright, so we go to page. How's everyone this morning? Page 197. Okay. Coordinate vector and change of basis. Okay, now what does the theorem means? Okay, if you have a set S which is a basis, you have until n okay, let S u1 until un, so the dimension of V is n, be a basis. I didn't say the basis, it's a basis, one of the bases of a vector space V. Then for every I use V in V, there exists a unique, okay, this is the word, there exists a unique set consisting scalars. Scalars are real numbers, C1, C2 until Cn, okay, such that this V is a linear combination of this vector. Okay, this comes from also the definition of spanning and the unique solution for determinant is not zero, comes from previous section. Okay, and when you write these CIs as columns, that is what we call coordinate vector. Alright? The coordinates of V relative to S are these colors. Okay, and the coordinate vector of V relative to S is, this is how you write V relative to S. Okay, and C1, C2, C. So you just collect all the C's, you write as column. This is the coordinate vector of V relative to S. Question would be, find the coordinate vector of V relative to S. So what you should do is to write V equals linear combination and solve for C. Solve for C. Sometimes we also call this as component of V. Okay, but I normally don't use this. We normally use coordinate vector of V relative to S. So how to find the coordinate vector is by writing out and solve for C. So this is back to chapter 2. Okay. Now let me give an example. Okay. If you have a standard basis, okay. If you have a standard basis like 1, 0, 0, 1 in R2, if you give any V like maybe 3, 4, right? Why sometimes we use like this? Why sometimes we use like this? Okay, it depends. Some authors, they use horizontal to save the space. Some authors, they write this or they write this. We can just stay with our normal 3, 4, right? Okay, now find C1, C2 in R such that V is C1, 1, 0 plus C2, 0, 1. So 3, 4 is C1, 1, 0 plus C2, 0, 1. Okay. If you solve this, this is straightforward. If you solve this, you will see 3, 4 equal C1, C2, right? C1, C2. So this gives C1 is 3, C2 is 4. So you will see it's 3, 4. So V S equals 3, 4, which is actually equals to the original V. So for standard basis, for any standard basis, the coordinate vector of V relative to the standard basis is just equal to the vector. Okay. So normally you will not be given S to be the standard basis, because it's straightforward for standard basis. So in my example 3.21, the coordinate vector is just 1, negative 2. It's just equal to x. So I have a note there, page 198. If S is a standard basis, then this is just equal to V. Let's change the basis with a different one. Okay. The second example. Let's change S to be 1, 0 and 1, 2. As I said earlier, you can write horizontally. This is just to match with the answer as V. Okay, and V is 1, negative 2. Right? So we change this. Find C1, C2 in R such that 1, negative 2 is equal to C1, 1, 0 plus C2, 1, 2. So from chapter 2, we just write as column. And then, but this one you can just put like this, right? C1 plus C2 is 1, 2C2 is negative 2. From here, from school times, C2 is negative 1, C1 is 2, right? That is from just because it's so easy. So you just use solving and then solve this one, replacing. If you want to use row operation, you can use this. Zero, 1, negative 1. And one more, negative R2 plus R1, 0, 1, 1, 0, 2, right? So this is actually your C1, C2. So Vs is 2, negative 1. 2, negative 1. It's not a matrix, yeah? It's a vector. Okay, this one, you need to use this instead of this. Because this is a vector, it's not a matrix. Coordinate vector. So, parentheses like this. And it has to be a vector. If you write like this, it's also okay. Okay, but normally we write it like this. Okay, so coordinate vector is just solving linear combination to get a C. And the answer is unique. You cannot find any other answer. Okay, because for this particular basis, every vector V has its own coordinate vector. Example 3.23. You're given a basis, so you will be given a basis. Now, that example is a little bit different. You are given the coordinate vector. So S is not a standard basis. 1, 0, 0, 1, 1, 1, 0, 1, 1. Okay. This is a basis of R3. Probably the first part will be show this is a basis. So you have to show this spans R3 and linearly independent. Maybe you can find the determinant, which is not 0, and then you mention about the coefficient. If Vs is 3, 5, negative 1, find V. Yeah, this is a little bit different, in which you are already given the coordinate vector, you have to find V. This is actually much simpler than this one. Okay, you just use the definition of Vs. You remember, if you have V is C1U1 plus C2U2 plus C3U3, then Vs is C1, C2, C3, right? So in this case, you are already given this, right? So you can just find V. So V is 3 U1 plus 5 U2 minus 1 U3. Okay. So this is 3, 8, 0, 5, 5 minus 1, 0, 5, 5 minus 1. Okay, so this is easier, but you have to remember the definition of the coordinate vector. Okay. Another one. Okay, I change the set S to polynomial, right? S can be this 1 minus x plus 3x squared, x squared minus 1 plus 2x plus x squared. Again, this is a basis, and the basis of P2. Okay. If Vs is 2, negative 1, 1, find V. Okay, V is actually in terms of polynomial. You have to find what the polynomial is. So this is just 2 times this minus 1 times second one plus 1 times the third one. Then you can solve. Okay, so 2 minus 1 is 1, and then x negative 2x plus 2x gone. 6x squared minus x squared is 5x squared. 5x squared minus x squared, so you get 4x squared, right? 6 minus 1 is 5, 5 plus 1 is 6. Okay, so this is 1 plus 6x squared, right? The third one is also similar, but with matrices. Alright, now suppose we want to change a basis from S to S prime. To change a basis, from S to S prime. Okay, now we have what we call a transition matrix. Okay, the next section is about transition matrix, in which you can change from one coordinate vector to another one. Okay, so we want to find this transition matrix. The coordinate vector of V relative to the basis S prime is equal to P times the coordinate vector of V relative to S. So this is from S to S prime, from S to S prime. If you want to change from S prime to S, then you put S prime here, S here. Okay, definition 311. Transition matrix okay. Now this is also will use row operation. Okay, so you really have to exercise, do lots of exercise if you are weak in doing row operation. Okay, let S and S prime be two bases of a vector space V. I will give you S and S prime. Okay, because for one vector space you will have infinitely many different bases. Basis is not unique. Okay, then the transition matrix. Okay, the transition matrix from S to S prime is a matrix P where the columns of P are the coordinate vectors of S relative to S prime. That is, if S is U1, U2, UN, and S prime is U1 prime, U2 prime, UN prime, then P is the column of P are the coordinate vectors of S relative to S prime. So U1 S prime, column. So this is the first column, this is the second column, up until the last column. Meaning, give me a second. Okay. Meaning you have to calculate each single one with respect to S prime. Okay. For each of this one, you have to find the coordinate vector, right? Or the C. So you will put for U1 all this, right? And find the C. For U2, okay, to find this one, to find this one. Call this C1, C2 until Cn, right? Okay. What you have to do is you have to write U1 is C1 U1 prime plus C2 U2 prime plus Cn Un prime. This is only for U1. Okay. For U2 you have to do the same thing, right? If you want to find U2, and if U2 is like D1 until Dn, okay, then this one is D1 U1 prime plus D2 U2 prime until Dn Un prime. And then you have to do until Un. So you will have to calculate this that many times, n times. But you can do the shortcut, you can do it once, because they are all the same Un. Okay, because when we do this, we put as column, right? We put the U as column and this at the end. I will show you how to do it shorter. Okay. Theorem 310, you just read through yourself. Okay, Theorem 310. Okay, let's do some examples. Example 3.26, page 202. Okay, now let S equal 1001. This is just the standard basis. Okay, S prime is equal to 1121. Okay, A, find the transition matrix from S to S prime. Okay, let me do this first. Okay, so to find the transition matrix from S to S prime, call it P, right? P is equal to, this is U1, right? U1 S prime, U2 S prime. Alright. So you will write 10 equal C111 plus C2 1. Let me write this as this: C1, C2, D1, D2. Oops. This is just, I don't have to write this, right? This is just the when you write the coordinate vector inside the matrix, you don't have to write double like this. You just write the inside, okay? Okay, now this one and another one is you have to write 0, 1 equals D1, 1, 1 plus D2, 2, 1. So this is what I mentioned earlier, that you have to take and write as combination of this, take another one, write as combination of this. So this is the transition matrix from S to S prime. So solving this, you can solve like this, right? 1, 1, 2, 1, 1, 0. Okay? So this one is negative R1 plus R2, get 1, 2, 0, negative 1, right? One more, negative R2, 1, 2, 1, 0, 1, 1, last one, negative 2 R2 plus R1, 0, 1, 1, 1, 0, negative 1. I can see only 48 of you here, or 46. What happened to the rest of the class? Okay, make sure you like the video so I know that you are here now. You cannot share the QR code if your friend is not in this class. Okay. Make sure you like the video, yeah? I can see only 47 now. It's actually very serious to scan the attendance when you are not in class. Okay. It is okay not to come because you have 20% of the attendance, because some students sometimes they cannot come because many reasons. Sometimes you are not well, you cannot come to class, you cannot even get up, and any other reason. But don't scan the attendance if you don't attend the class at all. Alright. Okay, so I finished. So what do I get? U1 S prime is equal to negative 1, 1. Okay, and then you do the same thing for this one. To get, you already get this, to get the second one. So you do the same thing, you see, sorry, you write the same thing, but you change only the n, right? So you do the same one, you will get negative 1 and add, right? Oops. You see, you get the same one, only this one is different. So negative 1 and add, negative 1 and add, you get 1. And then again you get negative R2 because they have the same left. Then last one, one, 0, 2, right? So U2 S prime is equal to 2, negative 1. 2, negative 1. So P is equal to -1, 1 to -1. We just take the inside of the column. So this is what they want. -1, 1, 2. This is the transition matrix. Okay. So what does it mean? You will see later, I mentioned about the shortcut. You can do this once. Okay. Instead of doing it twice, what you can do is to get this answer just once. Let me show here before I erase everything. Okay. So find the transition matrix from S to S prime. Find the transition matrix from S to S prime. So what you do is you put S prime first, and then you put S, and then you do it once. Then you will get at the end this and then this. Okay, so this is your S prime, this is your S. So this is the transition matrix from S to S prime. Okay, then this is your P. Okay, this is how you get to combine these two by definition to get P. Okay, it is in my example, so you have to go through each and every one of this example. 3.27, 3.28, 3.29. Okay, and then 3.30, and last one is 3.31. Okay, there is one more thing that I need to mention about the inverse later. Okay. Okay, there is a second question, right, for this one? Okay, what does it mean by transition matrix? You can change basis from one basis to another. So what does it mean by this? This is your V is R2. You have two bases. Okay, they can actually share the same vectors, but if you share, then one of the coordinate vector will be just 1, 1. Okay, and then this says that you can change from one basis to another by multiplying with P. Use formula of this to find Vs if V is 7, 2. You can find this two ways. Okay, one is to recalculate what does it mean by coordinate vector of V relative to S prime. Okay, by definition, I'm not using formula first. By definition, this means right, if 7, 2 is C1 S prime, right? 1, 1 plus C2 2, 1, right? And from here, you can get the answer by doing this. 1, 1, 2, 1, 7, 2. Okay, let's try to do this. 1, 1, 2, 1, 7, 2. I'm not using formula yet. I'm just doing first the by definition. What does it mean? If you want to find the coordinate vector of V relative to S prime. So 1, 1, 2, 1, 7, 2, negative R1 plus R2, negative 1 and add, then 1 and add, then 1 and add, negative R2, and one more. Negative 2 and 10, right? So you can check if this is right. You get 7, 2. Okay, so the answer is Vs prime is equal to negative 3, 5. Alright, negative 3, 5. But they want us to find using formula to find. Okay, so if you want to use formula, I erase this. I can just use this. So Vs P Vs. What is P just now? P just now is negative 1, 1, 2, negative 1. What is Vs? S is standard basis. So V based on the standard basis is just V. Okay, so just multiply. Negative 7 plus 4 is negative 3. 7 minus 2 is 5. So this is by using the formula. This is by using the definition. Okay, so that is example 3.26. Okay, now example 3.27 is to do the example with a different V. Okay, now they change the V into different question. Let me see. First, you find this, right? And then there's another question given, 3.27. You have to find with this. You have to find with this. You have to find with this. Okay, if you don't have this formula, you have to do the row operation like earlier with each of these. Okay, if you have to find using the definition, you will have to do the operation putting this and this as column and row reduce. But since you already know the P, to find Vs, you just multiply by each of these. So for this one, you just multiply here and you get the answer straight away. So that is why page 204, you just multiply to get Vs prime. Okay, otherwise you need to do row operation. Okay, now let me show you one theorem. Theorem 311. Okay. Let P be a transition matrix from S to S prime. Okay. This is the formula, right? Then P inverse is the transition matrix from S prime to S. So now go back to chapter 1. You have to remember how to find the inverse. Okay, so let's see the example that we did before. Example just now, I used the same example. S is 1 0 0 1, S prime is 1 1 2 1, and then just now we have P is equal to, what is it just now? This is example 3.26, yeah? 1 0 0 1, 1 1 2 1, and then P is equal to negative 1 1 2 negative 1. Okay. Okay. Before using this theorem, we can also find the transition matrix from S prime to S. Earlier, we put this first and this, right? Earlier, this is how we get P, right? We put 1 1 2 1, and we put 1 0 0 1, right? And then we reduce. Okay. Now, to find P, to find the transition matrix from S prime to S, call it Q. Q is transition matrix from S prime to S, from S prime to S. So we have to put the S first, and then this. Since this is a standard matrix, this is already row reduced. So this is the Q. Okay, so by using this, I get Q already. Okay, by definition, this is by definition, and you can see this is easy because this is already standard basis. But now I want to find P inverse. Okay, what is P inverse? Determinant is 1 over negative 1. This one we put 1 1 and then we change, right? Betul ke? The inverse. What is the inverse of ABCD inverse? 1 over AD minus BC until row reduce, yeah? For this section, it has to be row reduced, not only row echelon. What's the formula here? Ingat tak? Which one do you put negative? Which one do you change? Bagi jawapan. Apa tu? D. Nampak. Ya, A, D tukar tempat, B, C tukar sign, right? So this one is D, A, negative B, negative C. So, mana tadi? The inverse or this one? Okay, so this is negative 1, ni tukar 1, 2. Okay, and so this is equal to where is it? Yang saya salah tulis ni. Negative 1, negative 1. B and C. Apa dia? B and C. Apa datang ni? Okay. Ni betul Okay. Ini yang tukar kan? Okay, itu negatif. Okay, negatif tukar tapi dia sama Negative 1, negative 1 tukar. And then this one is just the negative. So negative 1, negative 2, which is equal to 1, 1, 2, 1. Right? So this is by taking the inverse, this is by taking the definition. Okay, so sama kan? Okay, Q using both ways. So if you have to use the inverse, then you have to use the formula for inverse, right? Okay, that's example 3 to 8. Find the transition matrix. Example 3 to 9. Okay. Again, do the same thing. The question pun memang macam tu lah. Find the transition matrix. and find using formula or find using the inverse of the transition matrix. Okay, let me do another question example. Kejap, apa 9 lebih. Okay, 329 ya. Tadi ada soalan if you had to do it REM or RREM. Yes, you had to do it until row reduced echelon form. Now S is 1 0 0 1 1 0 1 2 negative 1. Okay, this will be given in the question. 1 1 1, and normally if you have to find the transition matrix S to S prime, S prime to S, you won't be given standard matrix, but nanti standard matrix now to do the other one. Okay, so given two bases, 1 0 0 1 1 0 1 2 negative 1 1 1 1 0 1 0 0 0 2. If you are given a question like this in your test, saya dah lama tak bagi quiz susah juga nak bagi quiz. The important thing is when you rewrite the question, you have to rewrite correctly. Banyak kali every semester ada student salah salin soalan. The plus and the minus is this very careless mistake. Then you lose the whole question. Double check your vectors with the question. Okay, the question will be find the transition matrix from S to S prime. That is P, right? So call this U1, U2, U3. Call this U1 prime, U2 prime, U3 prime. So from S to S prime, meaning, okay, you have to find each of U1 from S prime, right? Since you have to write it accordingly to S prime, you have to put S prime first. So 1 1 1 0 1 0 0 0 2. For the first one, you put U1. Then I will do this once. Instead of writing this 3 times, I do it just once. Because this means that you have to write each one of this in terms of this, right? Okay, so just reduce this. Negative row 1 plus row 2, negative row 1 plus row 3. Siapa yang tak like tu haha tu kenapa tu? Why are you laughing for the video? Kena tulis sebab the video before this somebody was angry, I don't know why. Marah ke salah tekan, tak tahu lah Okay, 1 0 0. I just put like this Kena buat macam ni ke? Sebenarnya kena, because this is not a matrix, this is a vector. Okay, but if you don't write this, saya tak adalah tolak markah. Right, the right way is to do this, because this means it's doing it 3 times. Okay, -1 and add. Don't forget this one pun, ya. Okay. -1 and add. Okay. And this is already okay, this is already okay. This one you had to make it 1. So there is no other way. You have to do this. Okay. 1 0 0 1 1 1 0 1 0 -1 0 1 0 0 1 -1/2 -1/2 -1. So P is this 1 1 1 -1 0 1 -1/2 -1/2 -1. Now the second question is to find the transition matrix from S prime to S. Okay, so there are 2 ways to do this. You take the inverse of this, or you use the definition. So for the second part, sama je lah kesusahannya sebenarnya, to find the inverse pun. But inverse, you can opt to find it using the adjoint method if you don't really like row operation. So to find the transition matrix from S prime to S, okay, this is the other way around, in which this is a prime goes here, and this is the Q, right? Q, or you call it the inverse. Okay, now S, from S prime to S, you have to put S first. Okay, you have to put S first. Do this again. S first. So 1 0 0 1 1 0 1 2 -1 1 1 1 0 1 0 0 0 2. Ni senang. Because it's already 1, this is already 1. So you do this first, or you do this first pun boleh lah. You do serentak. Negative R2 plus R1 and negative R3. Okay. 1 ni yang tidak berubah. 0 0 1 negative 1 0 negative 2. Okay, 1 0 negative 1 0 negative 1 0. Okay, one more. This one done, this one done. This R3 plus R1 negative 2 R3 plus R2. Okay, so 0 0 1 0 1 0 negative 2 and add 3 1 4. Then add, right? 1 0 0 negative 1 negative 1 negative 2. So Q is equal to this, right? Negative 1, negative 1, negative 2, 3, 1, 4, negative 1, 0, negative 2. Okay? So this is Q. If you want to find using the inverse, you can do also. You have to take the P. You have to take the P and you do adding I, then you row reduce, then you get the same answer. So it depends on the question. If the question said use A to find B, use P to find Q, so that means you have to find the inverse, okay, to use the formula. The last example that I want to mention today is if you are not given in Rn, this is R3, it's the same thing, okay, it's the same thing if you are given as polynomial, because we have done this before. Okay, suppose it's polynomial. So this is example 330. S is 1 plus t, 1 plus t plus t squared, S prime 1 minus t, 2 plus t, 1 minus t minus t squared. Okay, so to find the transition matrix from P from S to S prime, sometimes I write like this: transition matrix from S to S prime is equal to, call this again, sometimes we use P, P1, P2, P3. This one we use Q1 as polynomial. Okay, so this is P1 writing in S prime, P2 writing in S prime, P3 writing in S prime. So although this is polynomial, okay, but it is still linear combination, this one is like writing P1 1 equals C1, right, in terms of this 1 minus t, C2 2 plus t, C3 1 minus t minus t squared. So if you remember last time we do matrix and I put here 1 t squared, then we can put C1, C2, C3 here, right? Then we do this. So we can do still the same like R3, okay, like R3, but make sure this is increasingly the degree of t, okay, increasing or decreasing, and this is increasing or decreasing. And sometimes the question, I don't know whether it's a typo or they mix up 1 plus t squared plus 2t. You have to rearrange, make sure it's the right arrangement. So in this case we had to put S first, right? You have to put S first and then you put the S prime first, sorry, S prime first. So 1 negative 1 0, 2 1 0, 1 negative 1 negative 1. Okay, back to like R3, and then we do it once. We put S 1 0 0, 1 1 0, 1 1 1. Again, you row reduce, then you will get P. Okay. Saya bagi 3 minit. Try to do this. 3 minutes. Try to reduce. Okay, yang dah hantar gambar, thank you. I'll keep that in one folder. If possible, use selfie, like with the whiteboard, with your laptop. Would be better than just your face, because your face you can put everywhere anytime. Okay. Let's see. So row 1 plus row 2, right? Okay. 1 2 1 1 1 1 0 3 0 1 2 2. Oh, negative row 3. 0 0 1 0 0 negative 1. Okay, I normally will double check every single row. Okay, otherwise you wait until the end, susah nak semak. So there is no other way unless you do this. Okay? Ramai student, they don't like fraction. I don't like fraction too. And you tend to use this. Okay? To make this one, you can only use the one under. You cannot use back the one on top. Because if you use this, then this kacau, okay, you will change this back. So you cannot use negative R1 plus R2 to make it 1, because you will use pusing dalam roundabout. So you cannot use, although very tempting, you can get 1. You have to use something kat bawah dia. But underneath, there is no more. So there is no other way. The only way is to make it 1 is to make it a fraction. Okay? So salin balik 0, 1, 0, 1/3, 2/3, 2/3. And then 0, 0, 1, 0, 0, negative 1. Okay. So you have to make this 0, negative 2, row 2 plus row 1. Okay, so you see I didn't put this. Sebenarnya dia macam ni lah kan. Okay, 0, 1, 0, 1/3, 2/3, 2/3, 1, 0, negative 2, and add. Negative 2/3 plus 1 is 1/3. Negative 4/3 plus 1 is negative 1/3. Negative 4/3 plus 1 is negative 1/3. Okay, then one more. One more is negative R3 plus R1. 0, 0, 1, 0, 0, negative 1, 0, 1, 0, 1/3, 2/3, 2/3. And then 1, 0, 0, plus okay, negative row 3, 1 plus 2/3, right? One-third, negative 1/3, 2/3, 1/3, 2/3, 2/3, 0, 0, negative 1. Okay, so that is your P. Copy balik So this is your P. Now to find your Q, you have to find the inverse. Or you can do this once again and flip, or you can find the inverse of P. So that is your Q. Alright. And imagine if I give you S as matrices, it will be 4 by 4. Okay? So you can look. Example 3, 3, 1. Okay? We'll stop here. And you can continue. No question about coordinate vector. Okay, so on Thursday, collect all questions that you have, okay, up until now, and I will continue with row space and column space, which is just direct from matrices. You just do row reduction, okay, then you'll get row space and column space. Okay, anybody did not get to scan earlier? Ada tak? Ada a few. Let me check attendance. Ada masalah sikit. Type dekat comment if you didn't get the attendance earlier. Saya tengok balik. Okay, semua dah. Okay, that's good. Sebab tadi ada masalah, saya tak dapat detect. All of you dah ada. Okay, fine. Nice. Ada yang belum ke? Tapi semua nama dah ada ni. Rafika, belum. Okay, I received some more photos. This is nice. Thank you. It's good to see how it looked like from your laptop. Okay guys, it's all for today. I'll see you on Thursday. Boleh sarapan? Siapa yang perlu sarapan? Bye bye. Okay guys, bye. I'm ending this now, yeah? Right, bye bye.